Okay, although we did a similar question like this last time, I like the concept because this is a rather very realistic scenario, right? You may run a business someday. Some of you may be CEOs or chief operating officers or something. So you may be making decisions about spending, and these advertisement costs can be very costly. And if there is no return on your investment, then you may have to switch your company that's doing the marketing, or you may have to figure out different venue for doing your advertisement and all that. So let's think about this question. So here's a solution. Suppose marketing companies, agencies or companies claim is true. Then if you call anyone, let's say the marketing company is working inside the United States and the claim is inside the United States, right? So if you contact a random adult in the United States and ask the person whether that person recognizes your brand or not, what's the probability of getting an answer as yes? So probability of response yes would be 0.4. Right? If 40% is the brand name recognition, that's what you would think, right? And now you want to think about how likely, if that's true, how likely getting 50 is. Right? So what probability should we compute? So we're going to first define the random variable x. X is the number of yes from 200. Okay? So it could be that you reached out to 200 and nobody said, "What? I've never heard of your brand," right? Or it could be that everyone says, "Oh yeah. I think your commercial was outrageously funny, and now I remember your brand," right? So it could be, so if you recall our discussion of probability distribution, see, the random variable x could be anything from 0 through 200, all the integers, so 0, 1, 2, 3, something like that, right? And it's very unlikely to have everyone respond yes. It's almost close to 0, right? Also very not likely to have 0. What's the most likely point here? Highest likelihood?
80.
80, because 0.4% of 200 is 80, right? So you have somewhere here 80 here, and that will be the peak. That will be something like this, right? And because there's so many possibilities here, even the probability of x being exactly 80 will be quite small. It will be definitely bigger than 1 out of 200, but it's not that big either. So let's try to calculate that probability. So we can use second bars. So if you have a calculator, please try this as well. Second bars, binomial PDF among 200 trials, and then probability 0.4, and then x value is 80, if I want to know what's the probability of getting exactly 80, that's only 0.057. So, so now you have to think about the significance of this 50, right? So you get a 50. So of course, probability of x being exactly 50 will be much less. Do you agree? Right. It will be much less. So how do you argue that this 50 is rather a small number? Instead of calculating the probability of x being exactly equals to 50, you're asking, what's the probability that you would get 50 or less? So you're kind of thinking of, like, even if you include 50 and before, this probability is very small. That's the argument that you can make. So that's the argument that you have to appeal to the marketing company. So we have to calculate this. What function in your calculator calculates this? Do you remember?
CDF.
CDF. What does CDF stand for? Cumulative distribution function, right? So you have to go to your calculator, click second bars, and scroll up to find binomial CDF. Put the trials as 200. Probability as 0.4, and now your x value will be 50 or less. Because it's a CDF, it doesn't compute just 50, it computes 0 through 50. Okay? And the result from the calculator is that it's 5.89 e negative 6. Okay, so can you tell me what this means?
10 to the negative 6.
10 to the negative 6th power. So that'll be 0.00000, 5 zeros and 589. Well, actually, the afterwards there's 889 again. So if you raise round to the nearest, it's like 590. That's a very small probability, right? And therefore, you can go back and tell the marketer, well, you promised us something like 35%, and now you come back and claim that it was successful as 40%. Well, we don't believe it. Here's the result. Okay? And then you can ask for partial money back or something, or if they don't give you money back, you can sue. The good thing about statistics is you can even use it in court. That is good. All right, so I guess the key here is that to make an argument that some number is too small, you don't just calculate the probability of that number, but you calculate the probability of that number and below. Okay. What if this was something like, what if you change the roles? Like the company claims, hey, we think your marketing firm didn't change anything. It's still 20%, right? You want to show that it's actually more than 20%. What do? You want to say that some number they got was more. Yeah. So in that case, you would calculate this to say that. See, with probability p at 20%, and you want to show that this 50 or more is rather larger than, I mean, it's hard to, the probability of getting a 50 is quite low if the p was 0.2. Then you want to show that this probability is low. So the inequality follows the direction. If you want to say, hey, you claim 40%, I get 50 is like 25%, okay? I get 25%. 25% is definitely low because I know the probability on the left side is very small, which is this one. So in that case, we go for inequality this way. if the role will reverse somewhat so that the marketing company wants to show that it's bigger than the 20% one, then you would be this one with the same result, 25%. So this will be calculated, and if this is a low probability, then you can show that definitely 20% is not the number. It should be something bigger than 20%. You have to understand this logic, right?